Okay, girls, we're going to move on to now to take a look at chapter 20. I know you're working your way through your theorems, and we'll continue to do 2 of them a week. So I'll do a video for the next 2 shortly, and then you can start working on learning those ones. But we're going to have to start to take a look at probably the largest section that's left over, which is the change in patterns. So the first thing we're going to look at, girls, and sorry, I had a stand for this phone, but I've broke it. So I don't know if I'm going to be able to do that anymore. So the quality is probably going to go down a good bit. Okay, I'm going to go back though and look at linear patterns, girls. So this was your chapter 5, so it's on page 101. This is an example, it's question 15. So you might remember you've seen these patterns a good few times, and I just want to remind you of what you used to do. Okay, so you've pattern 1, this is pattern 1, pattern 2, pattern 3. And then you might be asked to draw 4, 5 and 6 and work out the number of dots. So in the first one there's 5 dots, in the second one there's 9, the next one there's 13. So you see that the difference between here and here is you're adding 4 on, and between here and here you're adding 4 on. So we're going to keep going. You're going to add 4 on, so that's going to be 17. And you're going to add 4 on, so that's going to be 21, and you're going to add 4 on, and that's 25. Okay, and that's what we call a linear pattern. So that's a pattern that changes by the same amount. Sorry, that's going to be easier for me. That changes by the same amount as you continue on. You then had to create a general formula for this one. So your general formula was known as Tn, and this difference that you had gave you the n value. So you're multiplying each by 4, so it's 4n. And then you're looking to see, well, what do I need to do to get from this point to this point? So let's see what I mean. So for pattern number 1, if I substituted in 1 for n, so it'd be 4 times 1, I'd get 4. What do I have to do to it to get 5? I'd have to add 1. So that'd be 5, okay? So if we took a look at the second pattern, it'd be 4 times the second pattern. 4 by 2 is 8. And if I add 1 on, I get 9, and that matches. And the next one would be 4 times 3 plus your 1, which is 13. Okay, so this was your general formula. How do you get your general formula? You got your common difference and put it in front of n, and then you've seen what you had to do for the first and second one to get it to work out. Okay, and they were your linear patterns. And you were grand at them, to be fair. There was one on the exam, it went well. The general formula is hard, and it is hard to pull out, absolutely. But you were well able to do them, okay? And you've lots of different general formulas that you might get. So you mightn't get a drawing pattern. You might get something like 1, 4, 7, 10, 13. Again, if you take a look at this one, their numbers, they're all going up in 3s. So my general formula would be 3n. And then what do I have to do to the first one to get 1? So 3 times 1 is 3. And how do I get back to 1? I take away 2. And that gives me the answer 1. So I take away 2. I'll make sure it works. Then for the second number, it's 3 times 2, which is 6, minus 2 is 4, and that works for that one and that one. And you can check the third one, the fourth one, the fifth one, as many of them as you want. And that gets you your general formula. Okay, and they're what we call linear patterns. Why are they called linear? Because there's just one constant change. It's always 4. So if I was to plot the change, if I was to draw a graph of it, the change looks like that. It's always the same. For every single pattern, it changes by 4. Okay. Chapter 20 then takes a look at the next stage up and takes a look at patterns that are not linear, so that they're not changing by the same amount each time. So it didn't really matter which question I took a look at. I'm starting to take a look at page 400, question 6. And this is going to take you a while now because there's quite a lot of maths in this part. So we're just going to work on this table first, and then I'm going to give you a table, the next table down, to take a look at it and see if you can take a look at working that one out for me. Okay, so let's just take a look here. The first pattern is here and there's 1 tile. The second pattern is here and there's 3 tiles. Third pattern is here and there's 6 tiles. And the fourth pattern, I'll go to the book next, can't even see what I was trying to draw. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to fill that in. On the fourth pattern, there are 10 tiles. Okay, so let's talk about the differences. So going from here to here, or from here to here, there's a difference of 2. Okay, going from here to here, there's a difference of 3. Going from here to here, there's a difference of 4. Okay, so what I notice is in the previous one, the differences were always the same. We were going up in 4s, we were going up in 3s, we were going down in 7s, we were going up in 6s, whatever that might be. But in this case, those differences are not the same. So this is not a linear pattern. This is the next level up, which is a quadratic pattern. There are only 2 on your course, linear and quadratic patterns. You do have exponential graphs, but not patterns. So we need to take a look. If it's not, when you take a look at it, when you don't get the same difference each time, you need to go to the second line and work out the differences between the differences. So what the hell do I mean there? Well, what's the difference between 2 and 3? It's 1. And the difference between 3 and 4 is 1. Once you see that the second differences are the same, you'll then know that it is a quadratic pattern. And what do quadratics look like if I was to plot them? You've got your smiley faces and you've got your frowny faces that we had done just before the mocks. Okay, so let's come down here and take a look and see what we could see from here. The next difference then, it'll be 4 plus 1. The next difference would be 5, so that would give me 15. The next difference, it'll be 1 plus 5. The next difference would be 6. And 6 plus 15 is 21. And the next difference would be 7. And 7 and 21 is 28. Okay, how do I know? So the question's going to say to you to fill out this particular type of table. And it's going to ask you, how do you know that this is a quadratic pattern? I know this is a quadratic pattern because the first differences are not the same, but all of the second differences are the same. So what makes it a quadratic pattern is that the first differences are different and the second differences are constant or the same. All right. So if we take a look at the next pattern that you could take a look at, and let me just have a quick look now. So I'm here in the book. You can do it with numbers and there's loads of examples with numbers, but most of the ones that come up in the exam seems to have pictures. So I'm trying to get as many of the pictures as we can. So now compare the following pattern of rectangles here. So this one here. So you're going to do, it's page 401. So it's going to be page 401. And you're going to do question 6E. And I'm just asking you to fill out the table. Okay, so just fill out the table. And then we'll come back and take a look at a couple of the ones that just have numbers, like you see here. And actually you can do, when I'm taking a look at it, you can take a look at 5D as well. So that's page 399, question 5D. Okay, so there are the 2 sets of questions that I'm going to set for you. And I'll come back now and we'll take a look at the next stage then the following day. Okay, best of luck, take care.